Find the inverse of a matrix using Gauss-Jordan method. So this was your given matrix. This is your given matrix and you need to find out its inverse. The first step was write it in the form of A colon identity matrix. So it is of 3 cross 3. So we'll be taking an identity matrix of order 3. Then what I did, I have applied operation R3 implies R3 minus R1. R3 minus R1, just make to this entry as a 1 and then I'll swap it so that I can do my operation without fraction, right? If you have done it with fraction, then there is no issues. So after operating this, you are getting 1, 1, minus 1, 0 and 1. Now, next is we will interchange it. Just give me 1 minute, beta. Yeah, so we were at this. We have applied this. R3 minus R1. So we are at this step 1, 1, minus 1, 0 and 1. Then R1 interchange R3. So we have interchanged this. We are at this step. After that, what you need to do, you need to convert this given matrix into identity matrix and corresponding to those operation, whatever matrices you are getting at this place, that will give you inverse of that matrix. So my first target is I need to make this 0 and this 0. So you are applying the operation. R3 implies R3 minus 2 times of R1. Similarly, R2 implies R2 minus 2 times of R1. So I'm making this 0 and this 0 with the help of R1. So we are doing this, right? After that, I need identity matrix at this place, right? So you need 1, 0, 0 and 0, 1, 0 and then 0, 0, 1, right? So I need this entry as a 1. So what can I do? I can interchange these rows R2 and R3. So we are interchanging R2 and R3, right? After changing R1, R2 and R3, I need to make this entry 1, right? After making this 0, this is automatically 0 after swapping this. So next is I need to make this as a 1. So what we can do, we can multiply with minus 1 by 5 R2 and same I can multiply R3 with 1 by 5 to making this entry as a 1. So we are applying this 1 by 5 times of R3 and minus 1 by 5 times of R2. So after doing, we are at this step. Now this 1, 1, 1 is done. So what is next target? I need to make what 0? Tell me, beta. Anyone?
And the third element from the second row.
Yeah, third entry from the second row. I need to make this 0. So I'll make this 0 with the help of what?
R2 plus R3.
R2 plus
R3, ma'am.
R3 means using R3, we are making this 0. Because of these 0, it will remain as it is. And we want it as it is, right? If we are using R1 instead of R3, so we will spoil these entries, right? So we will make this 0 as well this 0. We can make these both entries 0 with the help of R3. So we are applying, we are at this step. So we are applying R2 implies R2 plus R3, this plus this, and similarly R1 plus R3. So after applying these operation, you are at this step. Now what next?
R1 equal to R1 minus R2.
R1 equal to R1 minus R2. Right? Why we are doing? Now next is I need to make this entry as 0. And for making this 0, I will take the help of R2, not R3. If we are taking the help of R3, तो क्या हो जाएगा? This entry would spoil. So R1 implies R1 minus R2. So after calculating, you are at this step. Now this is your identity matrix and this will gives you A inverse. Now check whether you are getting the same answer. Those who have done, Shubham,
Yes, ma'am. It's
same
the same
answer.
answer. Yeah, ma'am.
Everyone who have done it getting same answer.
Yes, ma'am.
I hope you have verified it also, right? So this was your Gauss-Jordan method. In Gauss-Jordan method, we can apply only and only row operation. No column operation mixing would be there, right? And using Gauss-Jordan method, we can find the inverse of any matrix, right? Now, this is one more example. You will solve it yourself. And this is your homework. We will try two more questions. Find the inverse of following matrices using Gauss-Jordan method. You can note it down or you can click it. Now, come to the next normal form of a matrix. Any matrix of order m into n can be reduced to the form this identity matrix of order R, and this is complete row 0, or IR and 0. This is again identity matrix or identity matrix, and rest of entry would be 0. If you can reduce any matrix either of this form, that is known as normal form of a matrix. And while converting into the normal form, you can use elementary operation. Elementary operation means elementary row operations as well as column operation. Then this R gives you the rank of that matrix, right? So we can find rank of a matrix using normal form. We can find the rank of a matrix using a row echelon form, right? So we have done the row echelon form and find the rank of matrix using row echelon form we have done. Next you can find the rank of a matrix using normal form of a matrix, right? So what is the normal form? Ultimately you need to convert the given matrix into identity matrix with the lower order. Right, so these all are your normal form. After converting into the normal form, so order of identity matrix will give you the rank of that matrix. So now find the rank of the following matrix by reducing it to the normal form. This is your matrix is given to you. Be ready with your notebook and pen. We need to reduce this into normal form. Can you tell me the maximum rank? What can be the maximum rank for this given matrix?
Ma'am, 3.
3. Very good. Because its order is 3 into 4. Right? मेरा maximum rank कितना हो सकता है? 3. This is a rectangular matrix and we do have the remark that rank of a matrix less than equal to minimum of row comma column. So first step would be I need to make it identity matrix. So identity matrix के लिए क्या करें? You tell me the first operation. What can I do? How can we proceed? Same, na? Criteria would be same. I need 1 at this place and then 2 zeros. right? So you will having the same process ki I need to make here identity matrix, and that depends upon identity matrix. It may be of 3 order, it may be of 2 order, it may be 1 order. That depends, right? So we need to try to convert this into identity matrix. So this is our goal. So this is our goal. We need to make matrix in this form. Either in this form means identity matrix of order 3 or identity matrix of order 2 or identity matrix of order 1. That depends, right? So this is our goal. First is operate R1 interchange R3. So we are interchanging it to make this first entry as a positive one. So we have done it, right? After that, we need to make this entry 0 and this entry 0. So apply the operation. R2 implies R2 plus 2 R1 and R3 implies R3 plus R1, right? R2 implies R2 plus 2 times of R1 and R3 implies R3 plus R1. Hurry up, simplify it and let me know what will be the entries.
Ma'am, may I?
Yes, beta, please.
Ma'am, the second row will be 0, 5, 5, 20,
Second
and
row
the
will be 0,
5, 5, 20,
5, 5, 20.
and third will be 0, 2,
Yes,
0, 8.
0, 2, 0,
8, 8, ma'am.
8. Okay, let us check. Absolutely right. 101, 110, first row as it is. Second is 0, 5, 5, 20, and third is 0, 2, 0, 8. Now, what next? I need here 1. So I can multiply this with 1 by 5. So do it. You will be at this 1, 1, and 4. Right? Next, what next? R3 implies R3 minus 2 times of R2. R3 implies R3 minus 2 times of R2. So you are making this 0 using this operation. So you are at this step, right? After that, this 0. So you need here 1. So multiply with minus 1 by 2, you will be getting it as a 1. Now what next? We need to make this entry 0 as well as this entry 0. So what you can write here, R2 implies R2 minus R3 and R1 implies R1 minus R3, right? With the help of this R3, we will make this 0 as well as this 0. After doing, you are at this step. Now, this is your identity matrix of order 3. You cannot reduce it more, right? But for the normal form, you need to make this entry 0 as well as this entry 0. So how can I make these entries 0? Anyone who can tell me?
But you can't, you can only make one entry 0 here.
Why beta? I need
Because,
here. Yes beta,
ma'am,
why?
because anyways we will subtract it by any row. It will
Mhm.
not be 0. Only one can be 0.
Uh, But there is no constraint, beta. You can use row as well as column operation because in I have told you use elementary operations. For normal form, you can use row operation as well as column operation. But in Gauss Jordan, there is a constraint. You can use only row operation. Why? Because I'm writing it like this. A matrix can be written as identity into A. Right? So when you are writing identity matrix prior to given matrix, so you apply only row operation. So there is a constraint in the Gauss-Jordan method. You can apply row operation, but in normal form, you can use elementary row operation as well as column operation.
Okay.
Right? Now tell me, how can I make it zero?
By column 4
C4.
column 4 equal to column 4 equal to column 4 minus 10 times column 1 and
Right?
minus 4 times column 2.
Yes. I'll make this zero with the help of column 1. So I'll write here C4 implies C4 minus 10 times of C1, right? And then after doing this operation, you will be at 1, 0, 0 and 0, 0, 1, 0, 4 and then 0, 0, 1, 0. Right? And then you need to make this entry 0. So I'll make this 0 with the help of C2. So again, we'll be writing C4 implies C4 minus 4 times of C2. So at last you are at 1, 0, 0 and 0, 0, 1, 0 and it is again 0, 0, 0, 1 and 0. Right? So this is your identity matrix of order 3. So you represent it like this, I3, identity matrix of order 3, and then just for representation, I represent this whole column, 0 column with 1, 0. Right? And this order gives you rank of this given matrix. This is the normal form. After converting the given matrix into the normal form, order of this identity matrix will give you rank of that given matrix. Right? So we will apply this and we are at this. This is the standard normal form containing identity of order 3. So therefore rank of given matrix is equal to 3. Right? I hope question is clear to everyone. You are very familiar with all these row operation and column operation, right? So you need to apply row as well as column operation in finding normal form of a given matrix. After converting that, order of identity matrix will give you the rank of given matrix. Right? So I hope you can done it. So note it down. I should not give you these answer, you know. Anyways, you will solve it. Find the rank of matrix using normal form. Note it down both questions. Now come to the next. Next is solution of linear system of equation. We have done what is the rank of matrix. We have done find the inverse of matrix using Gauss-Jordan. We have done find the rank of a matrix using normal form. Now next is solution of linear system of equation. I think you have done the solution of linear equation of system in your 12th standard. Can you tell me anything about what you know about this linear equation system? Nitesh,
Yes, ma'am.
what do you know about linear system of equation, beta?
And we have three variables in this. If two, three,
Hmm.
or if we have two equations, then we solve it to find the variables.
Hmm. What methods you have done in your 12th standard for finding the solution of linear equation system?
मैम ग्राफ्स वाले भी थे
Or
और मैम नाम भूल गया दूसरे का.
okay, no issues. Thank you, beta. So today we'll be doing solution of linear equation of system using rank. इससे पहले आपने grammar rule भी पढ़ा होगा, आपने graphical भी पढ़ा होगा, but today we will be doing solution of linear system of equation using rank. We do have two type of a system. One is non-homogeneous system of equation, another is homogeneous system of equations. Non-homogeneous system is written as Ax is equal to b, and homogeneous system equation is written as Ax is equal to 0. So let us see the non-homogeneous system of equation. Ax is equal to b. So you'll be having equation of system of equation like a11x1 plus a12x2 plus a1xn is equal to b1. Similarly, another equation a21x1, a22x2, a2n xn is equal to b2. Likewise, you are having m equations with n number of variables x1, x2, x3, x2, xn are unknowns variables, and you are having these m equation where bi's are not all 0. Right hand side of equations is not equal to 0. Right? If right hand side of all equations are 0, means all bi's are 0, then system becomes homogeneous system. Right? So this system, such type of system is known as non-homogeneous system of equation. All are linear equations. Right? So in matrix form, you write A, order is m into n, x, that is a column matrix of unknown, x1, x2, x3 up to xn, n into 1, and that is equal to b. That is your right hand side of this. This is again a column matrix with m rows. Right? So this is your matrix notation of this linear equation of system. What is A? A is the coefficient matrix, means A11, A12 up to A1n, A21, A22 up to A2n, likewise AM1, AM2, AMN. This is your coefficient matrix, order of m rows and n columns. Right? And this X is your column matrix with n unknowns, means x1, x2, likewise up to xn. Right? So coefficient matrix into this. When you will read, when you will product the taking the product of these two matrices, so you will read it like that: a11 x1 plus a12 x2. Right? Number of columns in this matrix and number of rows in this matrix are same. So product is possible and output would be of m into 1. Right? So this is matrix representation of this system of linear equations. Similarly, come to the homogeneous system of equation. In that Ax is equal to 0. It means a right hand side of all equations would be 0. So you will be having system of equation like this when right hand side of every equation is 0. So in matrix form, you'll write A into X is equal to null matrix. Right? So this is all representation of equation in matrix form. This A is coefficient matrix. This is the matrix of unknown, and this is the matrix for the right hand side of values of given system of equations. Now, this is your coefficient matrix. A11, A12 up to A1n, A21, 22. This is known as coefficient matrix. Next is augmented matrix. What is augmented matrix? A matrix involve, this is part of coefficient matrix, and then column B1, B2, B3 up to Bm, right hand side of given equations. So this is known as augmented matrix and this is known as coefficient matrix. I need both rank of both matrices to check whether the system is consistent or inconsistent. System is consistent or system is inconsistent means, if system is consistent, that means system is having any one or more than one solution. Right? If you are able to get the solution of given system of equation, then you can say that the system is consistent. Right? If you are unable to find the solution of system of given equation, then you will say that system is inconsistent. There is no solution. Now, if you have a system of equation just pick up the coefficient and put them in the matrix, right? So for this system of linear equation, coefficient matrix would be 3, minus 2, 5, minus 2, 1, 4, 1, 4, minus 7. This is your coefficient matrix. 3, minus 2, 5, minus 2, 1, 4, 1, 4, minus 7. Now, if you take the coefficient of matrix and add a last column with the constant, means you are adding one column with these entries, then matrix is known as augmented matrix. So how you'll write augmented matrix? 3, minus 2, 5, minus 2, 1, 4, 1, 4, minus 7. This is coefficient matrix, and then put either column or you can put a line. Then right hand side entry 3, minus 2 and 1. So this is your augmented matrix, and you represent augmented matrix with this A and then this symbol. Coefficient matrix is represented by only capital A. Now, consistency of system, that means the existence of solution. When a system of equation has one or more solution, then system is said to be consistent, otherwise inconsistent. When system has no solution, then system is known as inconsistent. If system is having unique solution or infinite many solution, then system is said to be consistent solution, consistent system, right? Now, inconsistent system, when rank of a coefficient matrix is not equal to rank of augmented matrix. When rank of a coefficient matrix is not equal to rank of augmented matrix, then system has no solution. Right? Then system has no solution. Consistent system. If rank of a coefficient matrix is equal to rank of augmented matrix, and that is equal to number of variables, then system has unique solution. If rank of a coefficient matrix is equal to rank of augmented matrix, and that is less than number of variable, then system has infinite many solutions. Right? So in these two cases, system is consistent, and in case of no solution, system is inconsistent. Right? So you need to concentrate at rank of coefficient matrix as well as rank of augmented matrix. So when you will solve the system of equations, so what you will do? You will write directly augmented matrix. Right? If you're having three equations with three unknowns or three variables, so you will write your equation like this: a augmented matrix a11, a12, a13 and b1, a21, a22, a23 and then b2, a31, a32 and a33 and b3. So this would be your augmented matrix. You need rank of coefficient matrix as well as augmented matrix. So if you are able to find the rank of augmented matrix, so from this only we can get rank of A as well as rank of augmented matrix. Right now, because the for coefficient matrix we need these entries only. Right? So for finding the rank of coefficient matrix or augmented matrix, so we just do the simple thing, write the augmented matrix and then find its rank. Right? After finding the rank, for finding the rank, what you will do, you will convert this given matrix into row echelon form. After converted into row echelon form, you will count the number of non-zero rows. Right? So if you are making, let us say, you made this 0 as well as this 0 and as well as this 0. Okay? Using row operation, you have made these three entries 0. Now you tell me what is the rank of augmented matrix? Tell me.
Ma'am, 3.
3. Right? Now I need rank of coefficient matrix. So what it would be?
Ma'am, 3 as well.
M
3
3.
is 3 as well. Very good. For coefficient matrix, we will forget this column. इसको हम भूल जाएंगे, right? And we will concentrate only on these entry. So for this coefficient matrix, again you are having number of non-zero rows are 3. So it means rank of augmented matrix is equal to rank of coefficient matrix. Both are equal and that is equal to number of variables. So in that case, system will have unique solution, right? Somehow, let us say you are at this step, right? After converting row echelon form, you are at this stage. Now, what is the rank of augmented matrix? What is the rank of augmented matrix? In this case, when you are having all these four entries are 0.
Ma'am, 2.
Why 2 beta?
3.
Ma'am,
3.
augmented. Oh,
Yeah, augmented.
ma'am, it will be 3.
3 na? For augmented matrix, I'll consider this complete matrix. So number of non-zero rows 1, 2 and 3 as well because ये entry आपकी non-zero है. So rank of augmented matrix would be 3. And rank of coefficient matrix? Because rank of coefficient matrix,
2.
I'll consider this part only. For coefficient matrix, we will forget this column. So in this, you are having 1 and 2 non-zero rows. So coefficient matrix का rank क्या हो जाएगा? 2. So this is the case of what? No solution. When rank are unequal, that means system has no solution, system is inconsistent. And last case, if somehow you are getting this entry again 0, right? So in the augmented matrix, again you are having two number of non-zero rows. So rank of augmented matrix would be 2 and rank of coefficient matrix again that is 2 and that is less than number of variable. So system will have infinite many solution, right? So in short, I can say that only finding the rank of augmented matrix, you can write the rank of augmented matrix as well as rank of coefficient matrix. But while finding the coefficient matrix rank, you forgot this column just to find the rank of coefficient matrix. I hope it is clear. Till here, any doubt? Okay. So, note it down this question. X plus 2y plus z is equal to 1, 3x plus 5y plus z is equal to 3, and 2x plus 6y plus 7z is equal to 1. Solve the system of linear equation using rank. Okay, this is your homework. You will do it. I'll give you the hint. You will write augmented matrix directly. 1, 2, 1, colon 1. Then 3, 5, 1, and then 3. 2, 6, 7, colon 1. Right? This is your augmented matrix. You need to convert it into row echelon form. So you will be making this 0 and this 0. So you will applying here R2 implies R2 minus 3 times of R1 and R3 implies R3 minus 2 times of R1, right? After making this 0, you will try to make this 0. So let us say this is again 0. Now, after this stage, you will write rank of augmented matrix would be equal to 3 and as well as rank of coefficient matrix is equal to 3 and that is equal to number of variable, right? So this implies system has unique solution. So after getting this step, both are same and that is equal to number of solution, number of variables, how you will write the solution? Come to this step. This entry is 0, this entry is 0, and this is 7, and then colon 1. So if I need to write out this row in terms of variable, so what can I write? Means in term of linear equation. So what you will write corresponding to this row?
Ma'am, z equal to 1 by 7.
Right, very good, beta. I can write here 7z is equal to 1. So this implies z is equal to 1 by 7. Right. Similarly, for the second row, you can write this is entry 0, means 0 times of x plus 5 times of y plus z is equal to 3. Now you will put z over here and you will get the value of y. Right. And then for the first row, from here you will be writing x plus 2y plus z is equal to 1. Now you have value of y as well as z. You will be putting y over here, z over here, and you will get the value of x. So this is your homework. You will solve it completely and then I will discuss in next class. Right? Any doubt till here?
No, ma'am.
Okay, beta. So that's all for today.